Before we get too far into this lesson, I want to talk for a second about this idea of conic sections. Conic sections means that it's a part of a cone, and truthfully it's part of a double cone, but for what we're doing today, looking just at the single cone makes the most sense. If you slice a cone directly across, then what happens is that the cross-section of that is a circle. If you slice that cone on an angle, you'll get an ellipse. If you slice from the base up an angle, you're going to get a parabola. And then the way that the double cone comes into play is that you would slice directly down between the two, and that's how we get what we call this hyperbola. So today we're going to focus strictly on the circle where we've cut directly across our cone. I am definitely assuming that you are familiar with circle terminology, particularly the center of the circle and then the radius of the circle. And the reason that something like a compass works is because you set one point down and you've got every single point equidistant from that center. That's going to be your radius. So what we've got and what we can do is identify a particular circle that has center of H and K and a radius of R. Then what happens is we get x minus the x value of the center squared plus y minus the y value of the center squared, and that's going to be our radius squared. It's actually easier to see in action rather than just hear it being explained. So find an equation of the circle. It's got a center of 3, -4 and a radius of 6. So what we're going to do is we're going to say, okay, well that's x minus 3 squared plus y minus -4 squared is equal to 6 squared. Now, of course, we don't leave things like this. This becomes x minus 3 squared plus y plus 4 squared equals 36. And just like when we had parabolas in the last chapter, the center of the circle is 3, -4, because of that minus that has to be there. Gets a little trickier when our equation is not in that really nice tidy form that we had before. What you have to do on something like this, you guys are gonna love it, is you gotta complete the square. So we have to, I like to rewrite these. So I would get x squared minus 6x plus y squared plus 2y. I'm going to take that 6 and bring it over to the other side. That's equal to -6. Now I have to complete the square twice. So I've got x squared minus 6x plus 6 divided by 2 is 3. 3 squared is 9. And then here I've got y squared plus 2y. Cut that in half, it's 1. 1 squared is 1. I've got -6 here, plus 9, plus 1. So I've got x minus 3 squared plus y plus 1 squared is equal to 4. My instructions were to find the center and the radius. The center of the circle is HK. So H is 3, K is -1. The radius is the square root of that constant. So in this case, it's 2. Now I know normally we say, oh, isn't it plus or minus? And that is correct. However, a radius in this case is a distance, so therefore it's only the positive. For the final example, it says that we've got the center of a circle, there's a radius of 5, and it's somewhere in the first quadrant. And we're told to find an equation if it is tangent to the x-axis at 1, 0. So on a problem like this, I'm going to do a quick sketch. tangent to the x-axis just means that it touches it in exactly one spot. That's a terrible drawing. And that's the point 1, 0. The center has to be here, exactly 5 units away. So the center of this particular circle is 1, 5. So if I'm going to write the equation of this, I would say x minus 1 quantity squared plus y minus 5 quantity squared is equal to, and then my radius is 5, so I have to square that, which is 25.